Today, we are tackling one of the most requested workflows in the ComfyUI ecosystem, high-fidelity face and head swapping, without using old-school face swapping tools that often look pasted on or lose the artistic intent of the model. What you are seeing on screen right now is the result of a 4K upscaled head swap using the Qwen Edit 2509 architecture. Look at the skin texture, the perfect anatomical blending at the neck, and how the lighting from the environment naturally wraps around the new facial features. This isn't just a mask, it's a structural transformation. If you stay until the end of the video, I'm going to show you a bonus refinement step using Z-Image Turbo and Seed VR2 that elevates these results from a cool AI experiment to a truly professional, production-ready asset. Let's get into it. We aren't starting from scratch because I always recommend building on a foundation that is guaranteed to work. We are heading into the official ComfyUI default templates to pull up the Qwen Edit 2509 workflow. When you first open it, you'll notice it's condensed into a subgraph. We're going to unpack that right now to reveal the core mechanics. Even though versions 2511 and 2512 are already out in the wild, 2509 remains a powerful, reliable baseline for these types of edits. Inside, make sure your model paths are correct. You need your diffusion model, the 4-step LoRA for speed, your clip, and your VAE all seated properly. The star of the show is the text encode Qwen Image Edit plus node. Unlike standard encoders, this has 3 image inputs, which is exactly how we're going to communicate complex visual instructions to the model. To keep this a controlled scientific environment, we are fixing our seed to 42. We'll start with 4 steps, a CFG of 1.0 and the Euler sampler. These are our baseline settings. For our first test, we have an image of a young Asian woman. To test the model's understanding, we prompt, "Make her sad." It works immediately. Then we prompt, "Make her cry." The results show actual tears. Now it looks a bit cartoony at these low steps, but notice what didn't change. The background stayed static, her facial structure remained intact, and the lighting didn't shift. This surgical precision is why we use Qwen Edit. Now let's push it. We're introducing a second image, a Western woman in a completely different setting. The goal is to migrate the face from our first image onto the body of the second. To help us track this, I've added the KJ node suite for better visualization and the RG3 image compare node, which most of you should have installed by now. We prompt, "Swap face from image 1 to image 2, swap only the face, keep image 2 pose and lighting." We run it at seed 42. Nothing. We try seed 43. Still nothing. This is where most people quit, thinking the model is broken. It's not broken, we've simply hit the limit of the base model's weights. To bridge this gap, we need a specific LoRA. We are heading over to Hugging Face to grab the BFS, Best Face Swap set. There are 2 versions we're using today, BFS Face V1 for surgical face-only swaps, and BFS Head V3, which is the 2509 recommended version for full head and hair replacement. Let's load the Face V1 LoRA first. This is designed to keep the hair, the head shape, and the jawline of the target body image while only painting in the features of our source face. When we run this, we see the swap happening, but there's a technical snag, pixel shifting. The output isn't lining up perfectly with the original body image. This is a common point of failure. To fix this, we use a native ComfyUI node, the Flux Context Image Scale. This is a crucial step. It resizes our body image to roughly 1 million pixels. More importantly, it optimizes the width and height ratios for what Qwen Edit expects. Our input was 720 x 1280, and this node nudged it to 752 x 1392. We run it again. Now, the face is swapped, the pixels match perfectly, and it only took 24 seconds on an RTX 5080. In our second studio portrait test, the face swap was successful. Following the official recommendation to use a more frontal reference image, we adjusted the angle of our Asian subject and reran the process. While the results are effective, there is an important nuance to note. Because we are using a face LoRA, the original Western model's jawline remains dominant. The result is an Asian face with a more squared structure. This highlights the distinction between a resemblance swap and a full identity swap, a challenge we will resolve later using the head swap technique. The official documentation for BFS suggests that for better skin tone matching, we should disable the 4-step LoRA, bump the steps to 20, and move the CFG to 2.5. This increases our render time to about 2 minutes on the 5080, but the result is much more natural. The skin tone now reacts to the shadows of the body image rather than just carrying over the lighting from the face image. Both the fast and slow methods are viable depending on your deadline. We tested this configuration again using our frontal face image and a seated body pose, and the results were impeccable. Now let's move to the heavy hitter, the head swap using BFS Head V3. This isn't just the face. This is the hair, the ears, and the skull structure. We swap the LoRA, bring back our 4-step lightning for a quick preview, and use a much more descriptive prompt. We tell the model to start with the body image as the base, remove the head entirely, and replace it with the head from the source image while maintaining anatomical proportions. On our first test, the Asian woman's head is perfectly placed on the Western woman's body. The neck looked a bit long, but checking the original body image, that was a characteristic of the base image, so the AI actually maintained anatomical accuracy. However, when we tried a different studio body image, we hit a wall. The contrast was way too high. It looked like a bad photo montage job. We tried changing seeds and lowering the LoRA strength to 0.8, but it didn't save it. This is the reality of pro workflows. We had to pivot to 20 steps, 2.5 CFG, and change the model sampling aura flow to 1.0. This helped, but it still felt a bit AI perfect and cartoony. The breakthrough came when we realized the body image itself was too clean. We switched to a more realistic, more noisy, less than perfect body image, and suddenly the 20-step render clicked. The hair, the expression, and the facial features were all there, perfectly integrated. This is a lesson for everyone on the Discord asking for a one-button workflow. There is no such thing. Professional results require you to experiment with your source material and understand how the model reacts to different textures. For those of you struggling with VRAM, there are 2 quick fixes to get this running on mid-range hardware. First, try adding the reserve VRAM 4 flag to your startup batch file to give your system more breathing room. If that isn't enough, I highly recommend switching to GGUF quantization models. You can find these on Hugging Face. The Q4KS version is only 12.2 GB, nearly half the size of the 20.4 GB FP8 version, making it much more accessible for 8 GB or 12 GB cards. I'll show you exactly how to swap your loader to the UNet GGUF node to keep your performance high without crashing your system. Finally, for the bonus tip I promised. If your result looks a bit too generated or smooth, we take that output and feed it into a Z-Image Turbo image-to-image workflow. We use Florence 2 Run to automatically generate a caption for our specific result and feed that into a K-sampler for a refinement pass. If you set your denoise to 1.0, it will change the image completely. Even at 0.5, it's too much. The sweet spot for professional refinement is right between 0.15 and 0.2. This adds that final layer of photographic grain and consistency. To finish, we send that refined image into Seed VR2. We upscale first to 1440p to check the details, and then we push it to a full 4096. The result is a high-resolution, professionally blended head swap that maintains the identity of your subject and the lighting of your scene. Stop watching. Start creating. I'll see you in the Discord. And that's the node, all open source. No filler. Thank you for watching. Grab the file, keep creating.